Okay, is my screen highlighted?
Yes, I can see it.
Okay, so Timechain summer of code. Rebecca obviously is the program manager here, the lead program manager, along with other project managers and
Mhm.
many other program managers to manage the scale of projects we are running. And let me just, yes, we have a team of designers as well working to help the projects have a good landing page and designs and logos. And the developers as mentors, as obviously the other mentors as well. HR and marketing team as well. The statistics is that we have around 1,000 contributors who started, and
Mhm.
with in that active contributors have are 600 right now, with 500 of them who completed the certification stage, who have got BSV certified, approximately 500, and 44 projects kicked off, with 41 of them having the white paper phase completed. And we have the program structured in phases. So the first phase was the learning phase, where people were learning about BSV and getting certified. And then the next phase, the white paper phase, in which they completed their white papers for the projects, doing the research, a lot of deep research for the projects, since they are pretty complex projects in many cases as well.
Mhm.
And the next part is the design phase, in which it's not just the UI design, it's also the technical architecture design, the database schema design, the API design, and all of that. So that is also very critical. So those phases are completed, and now people are in the development phase. We have been having the expert ed sessions. The always has
Mhm.
also had two sessions. Ty Everett had the sessions. There was an AI session by Konstantinos as well.
Mhm.
And yeah, the three phases have been kicked off. Some of the project logos to show just the kind of projects we are building. And here we go, the entire project board. And now I'm going to tell you about the entire schema of how the projects are working together in tandem to unlock the biggest potential that BSV can have. So in this,
Cool.
I'm going to cover um, from start itself. Let's cover all of them. So Bitcoin token standards. This one is more of a landing page where we have all the ERC standards that exist as of now, written out in how you do it in BSV and why it's better. So that acts as a tool for anyone who has been uh, using an ERC standard, of why they can be using the sCrypt based contract on BSV, to be using that instead. Um, and yeah, so that is having some projects. Already we have got obviously the ERC20 and the NFT standard, the 721. But there are more, and we had that entire team go through all the standards. There are very slight modifications on this. From the BSV perspective, it's very trivial. All these standards that exist in ERC, just some transaction modifications. Let's say fees is getting paid by someone else, that becomes a special different standard in ERC. But in BSV, it's very trivial. So like that, many things are there in there. So Bubble plugin, this is more of a plugin on Bubble, which is a no-code platform for having BSV blockchain integration for anyone building an app. Then the crowd compose. This is an interesting game that happened in Reddit. It's inspired by that. Our Place was a game that was popular twice on Reddit, with millions of people playing with pixels. So there were pixels in a big canvas, and people were actually editing those pixels and the colors in them. This is not too much on the main agenda of how the different projects connect the most important projects. But yeah, this is a interesting game where every pixel is tokenized and in a marketplace, so that a tragedy of commons that happened in the Reddit game doesn't happen. So it's a large canvas where people are having a marketplace for gaining ground on certain patches of pixels. And that's what happened, inspired by the game. BSV data is a data protocol competing with Ocean Network, which is there in the Web3 ecosystem. And it's more of standardizing data access and data gateways, along with metadata structure of how the data economy will work. So we had the team research the Ocean protocol very closely, only to be disappointed in its structure. It's
Okay.
not that good at all. Essentially, they
Oh.
have a data token, which is a Ethereum-based ERC20 token, which needs to be paid to access a link which is hosting data. That's it. And that link is encrypted. That link itself is encrypted and there on the protocol. If it is to be accessed through the gateway, which is the token payment. The token gateway acts as the ERC20 token, which is called the data token. That is a very shabby and not that much of a visionary way of how we envision the data economy to be on the BSV side of things. Um, but yeah, so we are having that done, looking at closely how the metadata structure will be there and how incentivizations can be built around it as well. So linked data economy can form. The vision of what is that economy called? Just a moment. The semantic web. Yes, the next
Okay.
generation of internet where the semantic web is there. That's also connected closely to that. Um, yes, in that comes uh, metadata is more important than data itself, as we know. So that is all formed on the metadata network, on the metanet itself for labeling data and then incentivizing data crawling, you can say. Um, and search engines might also be forming based on that. But yeah, I mean, this is too many things in one, but fundamentally, we just have to achieve at least a base level data standard where data is containerized and access control is there on BSV as a standard. Okay, so Meta Builder is a
Can
plugin.
can I ask something quick?
Yeah, yeah,
Okay, so okay, this is a little bit different from what I expected. I would love to stay here all day to hear each one of these. So can we? Because this probably we don't have the whole night to go through it. So can we?
yeah.
Because when we talked last time, I thought we were going to mostly focus on the tokenized or bridging other blockchain assets and then come almost like a migrate them to BSV, so to enjoy the efficiency and also the speed.
Yes, yes, yes. So
So
let's talk
so I
about
think
those three projects, yeah,
yeah.
which are critical
So and then I
to
would love to get you back maybe next week or sometime you can go through all of them. I would love to hear each one of them, but because of the limit of time, I would recommend. Is that okay for
Yes,
today?
yes, yes, it's better.
Yeah,
Yeah.
that would be great. Yeah, thank you.
Okay. So Bridge Token project here has the main focus of the maximum impact, as well as it's connected very closely to um, the month end
Securities
decks,
token.
the month end
The
decks
what?
as well. Yeah, the security token solution here, as well as the month end decks here, the
Oh,
decentralization.
math index. Oh, how about the voting token? That's also related, or?
Now, voting token actually is related to more of the DAO to build a proper
Oh,
structure of
okay.
how the
Oh, okay.
process
Okay.
works.
I see. Okay.
Yeah, and yeah, that's the most important projects we can say. There is also some more important projects, but yeah, not for our focus right now.
Okay.
Okay,
So
so
can you talk about just overall what are the objective and how the three almost like work together?
yeah, so security token solution is to make a standard or just make a solution on BSV that is using sCrypt, we already have that contract written that can have securities issued on BSV while still maintaining the properties of what we like from, let's say, a stars token. So stars token is a layer 0 token. It's not needing any off-chain agent. At the same time, stars token, but it is not having the properties of a security token system. Let me just get to the security token if I can. Mm. Okay, it's just going to be difficult to get to it. Yeah, here it is. Okay. Yes. So securities, to have company shares, to have real estate tokens, to have many different objects in life to be tokenized, they are all securities. And they need to be following certain rules and regulations that is required of securities to for it to be legal, right? So for even, let's say, Manthan Dex, if Manthan Dex wants to be the universal order book for everything, for every market, the most very popular and most used market is the securities market. So security tokens must be there, and they must be there the way the stars tokens are there as native layer 0 satoshis. So for that we need contract. We needed contract because that's already solved now. Needed the contract where tokens can be issued by the creator, the issuer, but then the token can be frozen because that's a regulatory requirement for security token, and they can be retrieved by the creator who issued it anytime they need it or require
Retrieved.
it.
That's what you call record. Is it take it
Recall,
back
recall.
basically?
Yeah, recall is the correct word.
Okay.
Yes, yes.
Okay.
The
Okay.
recallable token. Yeah.
Mm.
So essentially that we have done now. We also worked with a script closely to do that. So we have got the recallable token now. So recallable token achieves native layer 0 token that can be used as a security token. Since it's recallable by the creator, at the same time um, it can be frozen because if the freeze order comes, essentially it's like just recalling it. It's the same, pretty much the same thing. Though that recallable ability achieves a lot in that aspect. And rest of the tokens properties remain the same as stars token. And yeah, that achieves it, and it can be transferred, split, and merged. All that is there. Now that gives us ability to tokenize real estate, company shares, and everything else that is a security. So that's why it's important. And it can also be used, interestingly, it's not just about securities. It can also be used as a permission token or an identity token, which can be revoked because permissions are given and then they need to be revoked, right? And you need to be proving that you have a permission token. So they can be used that way as well. And we do use that in the DAO that we create with the voting token solution connected with this. So in that system, this acts more like uh, a permission token or a role token, you can say, which gives the role. Roles um, are essentially tokens that can be assigned and they can be recalled by the issuer who granted it. So the permissions also go away when that role goes away. The role token goes away. So if some other contract is written with this dependency that someone needs to have this role token, and only then they are able to do certain things in that contract. Let's say they are able to issue another type of token. Only the ones who have this role can issue this type of token. So they would need to have this role token um, and prove in that same transaction in which they are minting the new token that they want to mint to be able to have this role-based access control in the DAO, and that can go in complex organizational levels of the DAO, acting as that token for permissions. Because any type of permission can be used for any type of permission based on that other contract that is written. it's requiring any kind of role token for, and just like writing the simple logic that, okay, if this role token is spent, only then allow this to happen, otherwise don't allow this to happen. Simple like that. So yeah, with that, the DAO can be made in a complex way as well. So that is there. Then let's get to the, if I'm talking about the DAO, so let's even talk about the DAO fully then. The voting token contract solution. Already I see there's a way to do voting shown in sCrypt examples as well, but that's doing it in a different way. And what this voting token project contract is for is to not have any hash map in the contract. And it's using pure layer zero state of UTXOs itself as the state for the tokens, the voting tokens. So here, also the dependency is there on the security token solution as the role token, as I was sharing. So anyone who is a voter is having a role token. What is that role token? That role token is the proof that they are KYC'd. They have the ability to imagine they are a citizen. So they have a role token as a citizen, right? And this system scales tremendously because it's a layer zero independent type of token which doesn't need any other agent. So it just stands on its own as a UTXO. So then this, anyone who has this token, only they are getting the voting tokens in the first place, and they are able to vote, right? So that authorization happens there. So essentially you can use it even for KYC systems. This was required since even now, yeah, I totally forgot to issue a, actually in security token, I got a little confused. In security token itself, we had a requirement of 2 layers of token. One is the actual security token, the other is the identity token.
So
identity
another
token,
is what? Identity?
the permission token.
Oh, okay.
Yeah, the difference between the two is very, very trivial. It's only that the identity token cannot be transferred to anyone.
I see.
It can be issued and revoked. It can't be transferred.
Makes sense.
It makes sense, right? You can't transfer your permission or identity.
Then you are impersonation. Okay. Identity theft. Okay.
Yeah. So identity token once issued can only be revoked by the person who issued it and nothing else. Same with that's how it behaves as a permission token as well. Yeah, but it depends on how you want to use which one. The only difference in properties is that one can't be transferred, one can be transferred. Okay, so yeah, security token also had this dependency of its own on this other token. This was solved. This two tokens, one token as a requirement to mint another token was solved, and for that, I guess some updates also happened in sCrypt to enable that, and that's why that was required. And that is now achieved. So now next level is actually having a third layer, which is the voting token. That essentially completes the DAO structure fully. So, okay, now we have a vote issued as a token in the DAO, and the vote can be only issued, the votes can only be carried out by someone again who are KYC'd or who are a citizen. So essentially, they have some kind of a role token. Only they are receiving the votes. And the way even in security token solution, the way the role token is proven is that in the same transaction in which you, let's say, receive the, you are proving that you are eligible to receive the security token or the voting token only if you are also spending the identity token in the same transaction. So you are proving that at that point of time, you had the identity token, which was not revoked from you by spending it in that transaction. Same transaction. And that's the dependency of the security token, that the identity token is getting spent in the same transaction. And same with the voting token. So And yeah, the contract has been written for the identity token in such a way that it can be spent only to oneself. I mean, it can also, I was wrong on saying that. We had an update on that. It can be transferred, but only to oneself. So it can be transferred to prove in a transaction that they have the control over this token. They have this token right now with them, and they can prove that they still have it every time um, in a contract. That is a dependency that is written in the other contracts. So yeah, the voting token has the same dependency of this identity token, and then the voting token is accumulated. Essentially, the voting token you can transfer just like a security token, and it gets accumulated in a single person who is accumulating all the votes from people who is essentially campaigning. And well, we can put another role token for person who is eligible to be campaigning, but that hasn't been put as a requirement at this stage. It can be anyone who had the voting token. They can also be uh, participating as a campaigner who wants to collect votes. So the voting tokens are collected by one person, and essentially before the end of the campaign, and the time lock contract is there when the voting elections is going to end and votes are essentially going to be submitted. So one address is collecting all the votes, and in a single transaction of submitting the votes, one person has to submit all the votes that he has collected as the voting tokens to that address. I guess it can be multiple as well. That doesn't matter. But this address needs to collect all the voting tokens. And yeah, that's the end of those tokens. It doesn't go anywhere from there. The person who created that voting contract itself is going to also receive all the voting tokens. And that's how he's going to measure the last person to send the addresses which send the voting token are the ones who got the votes. That's how the vote is simply counted. How
Okay.
many votes were sent by which address to the final
Candidate.
address?
Oh, mm.
Yeah. So some candidates will essentially.
Explain that again. So it's not like you're casting a vote directly. It's how's the vote counted again? Can you elaborate? So
Yeah. So the
you
vote,
use this token. Okay.
you are sending this token. Essentially, you are burning the token by sending it to the counting address, and you have to send all the votes you have collected there.
So, okay. So you first send it to the candidate, and then the candidate burn it, or how's that?
Yeah, you
Is
first
that
send it to the
the
candidate, and then the candidate burns it.
okay? Why is this design? I just trying to understand because usually it's like oh, voting. If the way I think about it is like you have candidate A, B, C, and then if one is eligible to vote, they will just click A or B, and then the counter increment it, and then you just see the final result, right? So
Because the mapping,
how
the
many?
mapping of the votes, there's two problems that are solved if you do it this way. So the counting of the votes is very trivial, and there's no mapping between which vote goes to which candidate.
I see.
That becomes
Okay.
very trivial because that is done by UTXOs itself. The transaction itself did it. That this person voted for that candidate, and that candidate was able to
Uh-huh.
even counting was also automatic because the contract didn't even bloat. That mapping doesn't exist. That state doesn't need to be maintained in that contract. Utilize the ledger for that. Um, so that selection, otherwise you have to do right. Each vote has to have that state of which candidate it is selecting.
So by dividing into these two phases, what is the problem that is
The
solved?
state,
I'm just trying to understand.
the
Huh?
the state of the mapping from the votes to the candidates is also done by the UTXOs automatically.
Okay. And the benefit is, so here you want to keep the voting choice private or not? I'm trying to understand the rationale here. So do you want to see Alice voted for candidate A or you want to hide? Is that a design criteria here or it's not related?
No, that is not a design priority.
Okay.
But we will be able to achieve that also.
Mm. Okay. So, so the way I understand here, this security token solution that enables you to issue,
Essentially, imagine
specific types.
in DAOs, many times you have um, imagine proof of stake networks. They do a delegated proof of stake, right?
Mm-hmm.
So even delegated proof of stake, this functions essentially like delegating a stake to someone.
Okay. Oh, so you're delegating your vote to let's say the
Yes,
candidate, right?
yes.
Okay. Okay. So I just want to, again, how to see these three projects kind of integrate together. So once you have the tokens, you can tokenize, let's say any assets, and then you use the bridge to bridge it to the DEX. Is that the idea or
Oh yeah, coming to that part.
yeah?
But yeah,
Yeah,
this
the
voting
big
goes
picture.
to a
Yeah.
different, voting goes to a different realm than the DEX. So the DEX comes in, and for that, we have two more important projects, which is the bridge token. So I will
Mm-hmm.
explain the bridge token first. We already got the security token covered for the company securities and normal securities of the real world assets. But now to have the DEX function also for the crypto ecosystem, we need to be bridging or wrapping the assets that exist on the other chains on the BSV chain. The idea for bridge token is inspired from how Polygon gained a lot of traction in the initial phases when it got born as the Ethereum scaling solution and the Ethereum killer. And it bridged every ERC20 token, had the ability for any ERC20 token to run and gain from the scalability and low transaction fees of Polygon. And that's how it got a lot of traction. Now, on BSV has the same properties. It had it before Polygon of scalability and low transaction fees. And if we have the bridging solution for any ERC20 token and Ethereum and BTC to be bridged on BSV, and a wrap token be there for BTC as well as Ethereum as well as other ERC20 tokens, then we have BSV used as a bridging layer for a scaling solution for multiple different chains. And that will likely bring a lot of traffic, especially when there is a DEX supporting these tokens and it becomes a liquidity center.
Makes sense. So how okay, so for people who don't know much about Polygon, can you give a just short introduction how they work?
How Polygon works?
Yeah, so is it okay, so here's my okay. So if you
Yeah,
have
go ahead.
any kind of asset, let's say on some other blockchain, but it's slow and expensive, so you can almost like a move this like a one-to-one to the wrap token on Polygon, and then you do whatever there, trading, staking, whatnot, transferring, and then you can convert it back to the regional chain. Is that the idea?
Yes, exactly. That's the idea.
Okay. So we want to pretty much do the same, but using BS3 because we think
Yes.
it's more performant. Okay. So for there, the bridge has to be trusted, is it?
Yes, most of the bridges there are trusted bridges. I don't think there's a solution fully for a trustless bridge, and that's why the bridge hacks keep happening as well. Um,
Mhm.
but yes, I was considering how we could make a trustless bridge, and that derives the ideas from the cross-chain atomic swap of how we have it, and how you also demonstrated.
Mm.
If the cross-chain atomic swap can happen in a trustless manner by using hash time lock contract in which the atomic swap needs to happen, the similar manner we can create the contract where instead of BSV getting transferred for BTC in that locked account, it is the minting of the wrapped BTC when BTC is transferred in that account.
So, and there's wrapped BTC or whatever wrapped token is going to be the security token here. Or it doesn't have to
Um,
be.
it doesn't have to be. It can
Okay.
be a status token also. I mean, it's probably better for the crypto ecosystem. They don't have the requirement of securities laws, so they
Oh,
might
okay.
want a
So,
status token. Yeah.
oh, I had assumed this the when we say these three what kind of work together is may not always, right? The security tokens, the bridge, and the DEX. So seems it can be a security token, but it may not.
Yes, but we have to support
The wrapper.
security tokens also because the company shares in the DEX have to also be in the DEX, and they are security tokens.
Okay, but the wrapped tokens can be
Yes.
what kind of token will be that?
I'm assuming they are stars, and stars works for them right now.
Okay,
Yeah, they are essentially
okay,
stars tokens.
okay. So once we convert it to token to wrapped tokens on BSV, how does the next will be the DEX, right? How does that work?
Yes. So the DEX has, in fact, this also hasn't been solved fully by the rest of the ecosystem as well of Web3. They
Uh-huh.
have many fancy things, but they don't really have the true DEX, which is having an on-chain order book and
Mm-hmm.
matching agents. So drew a very good diagram explaining all of it. Let me try to open that up. In the DEX part, I mean,
Mm-hmm.
just a moment. I hope I have the Miro link for it. Nope. Can someone send me the Dex Miro link that we created? Just a moment, guys. It's in the WhatsApp group of the Dex. One second to get it. Yes, got it. Okay.
Right.
Okay, can you see my screen?
Okay. Yes. Can you make it bigger?
Yes.
Okay.
Okay.
All right. Yeah. That's part I'm most interested in. Anyway.
Yes. So what is an order? On-chain order book is what we're talking about.
Mm-hmm.
So every ask order is a transaction creating an output, and every bid order is also a transaction creating an output. This is how any market looks like, right? Bid orders
Mm-hmm.
on the BSV
Mm-hmm.
base, and these are ask orders on the BSV base. This is where the actual matching happens, and this is the DEX. So there is different price points. These are all in Satoshis. So accuracy level, order book precision has been chosen as 100 Satoshis, right? So every
Okay.
price point can be 100 Satoshi, then the next price point is 200 Satoshi. Next is 300. This has been chosen as it can go down to 1 Satoshi as a precision. Um, but right now we have chosen the 100 Satoshi precision.
Yeah, that's
By
fine.
that,
Mm-hmm.
by that I mean essentially, if someone is having a price placed for 150 Satoshis, that can't happen. That will just get matched with either 100 or 200. We have chosen a lower amount, so 250 goes to 200.
Okay.
So yeah, that's the price points at which the matches can happen. Um, then we have multiple orders, let's say, can be placed at a single price point, right? So the volume in total for 13 BSV can be there on a single price point, putting bid orders with the three different outputs or transactions, putting in 1 BSV, 2 BSV, 10 BSV, bidding for the same price point or ratio, we can say, same price point. So ask orders are also similar. In this side, multiple tokens are put on stake. By putting this on the transaction, I mean they are essentially locking it in the escrow, that until it is getting matched with a token of the equivalent ratio, only then the swap is happening, with this token getting unlocked and sent, and Satoshi is also getting unlocked and sent in the same transaction, the atomic swap happening. After the trade match is essentially the atomic swap.
So
And until,
every okay,
yeah,
every trade ends up with a on-chain transaction, right?
yes, every trade is an on-chain transaction, and every ask and bid order is in the mempool, is with a partial transaction which has
Okay.
not been matched. It has not been filled yet with the other outputs that are required.
Okay. So it's not
So
a complete transaction, you're saying.
yes,
It's
it's not a complete transaction. Essentially, that
okay.
or what I'm thinking is, yeah, there's two different ways of doing it. Um, so I'll discuss this. This is the contract requirement of the ask order, and this is the contract requirement of the bid order. The contract requirement of the ask order is that one token, ask is essentially the person who is owning the token wanting to sell it, right? And bid order is essentially the one owning Satoshis wanting to buy that token, the bid order. So let me first discuss the bid order then. So Alice is bidding for the price of 1400 um, by Alice. So she's keeping 1400 Satoshis in a locked state in an output, and having the demand of one token. So only when one token is sent to her, at that point, the 1400 can be unlocked from this locked state. So that happens in the same transaction. This locked state getting spent and this 1400 getting received happens in the same transaction, the atomic swap between this token and BSV. So that is a requirement of the bid order, that she's keeping it in locked state. Now, it should not be unlockable by any other price more than one token, right? Um, if if uh, if less than if it is more if the price is more than 1400, then then essentially she will be receiving some amount less than that token requirement. So she's essentially placing a requirement, a minimum requirement of the tokens she need to receive in order for these coins to get unlocked, right? Then it should be retrievable without matching, as you also mentioned in the atomics
Mm-hmm.
cross-chain atomic swap requirement, that the buyer should be able to walk out with the money and basically cancel the bid order. The
Mm-hmm.
cancellation of the bid order should be possible, so it should be retrievable without matching. It should be able to be matched partially in volume. That's the last requirement.
Okay.
Um, and the same is with the ask order. One token by Bob in locked state is locked, and the demand is that he's asking for 1400 satoshis in order for the token to be unlocked. And it should not be unlockable by any other price less than 1400 satoshis. Right? So that is his demand
Okay.
essentially.
Mm-hmm. Mm.
And it should be retrievable without matching because ask
Yeah.
order can be cancelled. The same thing. And then it should be able to be matched partially in volume. The same thing applies in the ask order as well from the token side. So then these two, when they're having the same ratio, that they are selling token at 1400 and this is wanting to buy the token at 1400, which is happening here. This person was willing to sell the token. One person was willing to sell one token for at 1400, and another person was willing to spend three tokens at 1400 ask orders. So here the taker is coming and matches to existing price by the maker. So this is an existing price. He's the maker because he has made the order. And this person who's having urgency is being the taker, who is taking this, uh, matching this price exactly and taking this money by spending giving 2800 satoshis and having the same price point of 1400. So essentially, he's wanting to buy two tokens. Now, either the partial volume match is a requirement because he's wanting to buy two tokens. So he can get one token matched here with this seller and one token matched from this seller, or he can have both token matched from this seller,
Okay. Mm.
right? So that's why the partial match requirement is there of that to be achieved as well. Then we have the true DEX functioning, in which the atomic swap happens and everyone is dealing directly on the blockchain following this protocol. And this protocol also has incentives for people to fill the order book, and those are also natural. The incentive is essentially taker pays for everything. This is how DEXs function. Half of it goes to the maker, half of it goes to the matcher or the platform. And who is the matcher? The matcher is the person who matched this to this ask to this bid. I mean, this bid to this ask. And there can be anyone. We'll start with these prices, but anyone can compete and be maker and matcher. And this price also finally goes to floating on the market in the last level. But yeah, right now it begins here. So if 0.1% is paid by the taker, 0.05% is going to the matcher, and 0.05% going to the maker. The maker himself could act also as the matcher. Uh, but yeah, that's another case. He can also, but this ability is given to matchers to exist. So yes, this is the requirement, and we are then making this contract. These contract is also very trivial. I think it's already achieved. It's atomic swaps that already exist, let's say in stars tokens. with BSV. So they can already be done. It's not that difficult. And yeah, if we have that, and then we have the stars tokens as the representing the wrap tokens of BTC, then we can have BSV getting traded with the wrapped BTC tokens as the stars tokens.
So the matching, is it done on some kind of like a server, or is it fully on chain also?
The
Order matching.
matching, no, it's an agent off chain
Oh, okay.
who is triggering the
Because
transaction, matching the both the orders. And there are people openly competing to match. So it's an open marketplace between agents
I
to
see.
match
Okay.
orders because they can see both the ask
And
orders and bid orders, and they're trying to get more and more takers. So it's open totally for anyone to compete and match. And matchers will be probably even having their own offerings. And even
kind of like a
there
market
not
maker.
just
Yeah.
one, yeah, there is not just one matcher essentially. It's a market, it's multiple people competing. If there is
Okay.
any two transactions matching in price and no one has matched them yet and created a trade, then that's an opportunity for the matcher to match them and create the trade and take the fees from the taker for providing the match.
Pretty much like a market maker to me.
Yes, yes,
Okay. But the difference here versus like centralized exchange is this is anybody can see all those orders and they can do it if they
yes,
want. So it's like
yes,
almost like this DEX is not a DEX, it's a DEX protocol. So anybody who wants to, participate, they can do it.
yes.
They don't
They
have to
can
go
just,
to your site.
yeah, yes, they
They
don't
don't have
have to go. It's the global open DEX protocol.
okay.
And that is not only for crypto, but also with the security tokens coming in for everything. Is the DEX for everything.
Mm,
Because everywhere there is a market, even in company shares marketplace, there is this match
mm-hmm,
making the same thing happening. On real estate tokens, also the same thing happening. This is everywhere happening. This is the essence of the entire DeFi space.
mm-hmm.
I mean, the good part of
How
it.
does this okay? How does this compare? Let's say compared to Uniswap type of AMM DEX. So,
Mm,
or simply put, why not just get AMM style?
nah, the
So
AMM
here, this
style,
is mhm,
from my perspective, I'm just building from first principles. I haven't
mhm,
looked fully there of how Uniswap functions, but what I know is Uniswap doesn't have this kind of an open competition for matches. It's a centralized uh, matchmaker still,
okay,
and only the people who are investing in the liquidity pool are getting returns. That is what is promised, and the agent, once the single agent is earning money and giving the profits to people instead of this way of structuring things.
yeah, it makes sense because the problem if you want to do the okay, that's my point. I think that some people they try to do the AMM style on UTXO, but then it's not efficient because the whole that's a you have a liquidity provider, right, which is a pool, liquidity pool, and this pool there's only single instance. So every trade against it has to spend a single UTXO and then cause a lot of contention issue. Then it becomes serialized, right? Because at any given
Yes.
time, you only have one pool and everybody has to trade against it. So then it causes a UI issue because if 1,000 people try to do the same thing,
Mm.
only one of them will succeed.
Yeah,
All the
this is
99,
this is
99, it
this.
will fail and retry. That's a UI nightmare.
Oh,
This actually
yeah, that
happens
is.
on Cardano. It brings Cardano DEX down pretty much. Yeah.
Yes, they have truly
So
on-chain order book. I think that was there as a project. I'm not sure.
Yeah, basically they try to simulate the AMM on UTXO, but then they found out there's only one UTXO you have to trade again. So it causes
Okay.
like a collision. So you every time a lot of people trying to make the same trade, then they all like all but one six fail. So then you have to come back and resign. Then it's a nightmare. Okay. So yeah, I'm good. This approach. I think the only thing the new things to me, the interesting to me is the partial matching, because if you don't do the partial matching, then it's very hard. But a lot of people do the UTXO based order book. I wouldn't say not. Some people, but historically it's not been good because you almost have to find the exact match. Otherwise, it doesn't go through. That's cause a liquidity issue there. So I'm interested to see how this plays out. You have the partial matching, right? So the part,
Mm.
let's say I want to buy two, let's say you put it here, three tokens, and then I only partial match. I get, can you like this? Yeah, you want to buy two. So if
Mm.
somebody wants to sell three, it's going to be like a state for contract here. So you update the state, you're still selling, but then you are selling two less. Is
No, no,
is
no, no,
about
no. We
right?
don't make it that complex.
No?
We will make it the way that stars functions, right? Um, we'll have one trade to split one. There will be two transactions and that are chained um, in one. Essentially, stars tokens can be split, right? Split and merged. Same with
Uh-huh.
Satoshi's as well. They also get split and merged. So we don't have this issue much. We only need to check the,
Okay, kind of similar.
yeah, we don't care that much if the receiver is receiving in even in three different outputs the same amount, or they're receiving in one output the same amount. Doesn't matter.
Hmm. Okay, that's simplified. Okay, I kind of get what you think. Okay, is that a white paper for this too, or it's not the diagram?
Um, I think it's not, all of this is not written. This diagram is the best
Okay,
representation.
okay, yeah, there we go. Can you also share in the group? If you can make public, can you also share in the group? So put in the show notes. Okay,
Uh,
yeah,
okay,
this is
I'll.
cool. Yeah, I think this is yeah. I'm. Anybody else has a question? Because I kind of get the I think I get the rough sense, but I still need to dive into details to
Hmm.
draw some pictures maybe to help me remember. But it seems cool. Yeah, the partial matching. I think that's a key innovation. And then use the yeah called atomic swap. But and another way is to the yeah depends on how you define atomic swap. But another way. So here for the swap to happen, is it you need both the seller and the buyer to sign this, or how does this work? So can you go down?
Yes, 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 yes. They have to
Okay,
sign
here.
this. Yeah, yeah.
So at the
They have
beginning,
to.
it's like a partial or
They are
not
keeping it in,
unsigned
no, no, no.
transactions.
Actually, they are keeping it in a locked state, right? That's
Okay,
why they are makers. You know why makers earn money and why takers pay money is because of the urgency. The difference is only in urgency. The makers are willing to keep the token in a locked state for a long amount of time at a particular price
okay,
because they only want it at that price and they don't want it at current price, the best price currently there. The taker
mm,
is taking it at the current best price and they can't wait. They can't wait with the price that is good for them and become a maker. So that's why they pay the premium for it.
okay.
And other people also parted with their money and they couldn't do anything else with it for that amount of some amount of time. So they should be earning money. So that's the
So
natural incentive for makers to be earning
mhm.
money, the incentives, because they're locking in money. So more and more people are coming in and locking in money also at the different price points because they can be makers and earning money some of Bitcoins.
Okay.
Okay,
So
but
is
coming
there
to the
any?
answer you asked, you asked me how the token is in the locked state, right? Whether it's unlocked by the signature or
Mhm.
Yeah, this is a special signature only that unlocks it. It depends. I mean, when the contract gets constructed, we might have to not have the signature. This part is not full. The contract hasn't been made yet, so I can't claim that is going to be having the
Okay.
signature.
So okay, I'm not even okay. Even before the details. So is this a? I assume that this is non-custodial, right? At any given time, anytime, the
Yes.
user has full control of his own funds, right? No, there's no
No, no, no.
escrow or
One
whatever.
second. There is no escrow, but he's keeping it in a locked state that can be unlocked only by his own signature or unlocked by
Uh-huh.
having the swap happen.
That's right. Yes. So it's not like a centralized exchange. You are moving
Yes, yes,
to
yes.
some. Okay. Okay. So okay. That's one way to do this in kind of smart contract way. That I don't know if you've seen this. So the diagram on the left reminds me of the, if you know about how ordinals are traded, they also use this technique called partially signed Bitcoin transactions. PSBT. Have you heard about this? So
Oh,
that's
yes.
another way. Yeah.
Hmm.
So just an option to think about too.
Hmm.
So there are two ways, right? One is using smart contract, make sure, hey, only you send to this specific address this amount, then you can unlock the ordinal. Or you find a match and then both verify the detail and then they each sign. So I have two inputs, two outputs, they swap ownership.
Yes, yes, that's what I was saying. There is two ways to do it. Either we have the swap happen, or we have a contract enforce. So my question is also, how does atomic swap happen on on stars token?
That part I'm not sure. I think it's yeah, I think here yeah, yeah, it depends on how you define. So the example I published is called a cross-chain atomic swap. I mean, you
I
can
know, I know.
do the
That
same
is cross
thing.
chain. Yeah, that can be done.
Yeah,
But
the
how
same
is
idea, but it's not using the idea like using same pre-image to lock
hmm,
in some kind of like
hmm.
hash lock, which is not happening here.
But here I think the hash lock can be used when it is in the lock state.
Hmm.
Uh,
But the
the
lock
hash,
can be just, hey, you pay this much, right, to this.
yeah, actually. Hmm.
So in that sense, yeah, it
It
depends
can
on
be.
that. It's still make sure atomic, but it's defined in the contract itself. It's not using the typical hash time lock thing. But that doesn't have to be. It's always a tool. So depends on use case. If it works, it works. So I wouldn't worry about too much about that.
I
So but
think
certainly yeah.
the answer is pretty simple. We are going to just make this pre-image that we are writing, right? For this token that is locked. For this locked token to be spent, we have to write the criteria that the pre-image that is getting signed, which is this transaction, the number of output is going to be some amount, which is this amount for the other token, for the other star, the other token, which is assumed to be a stars token as of now. So if that is there, then the number of outputs that this person, let's say Bob, is demanding is that he is demanding 1400 Satoshis as the output. That's written in the pre-image constraint itself that
Yeah, that's
1400 Satoshis is demanded as the output in total. Doesn't matter if it is one output or two outputs. He just wants 1400 Satoshis given to Bob's address, the same address that is unlocking this token.
yeah, that's one way. Yeah, you can do it in a contract. But also, I'm saying is another alternative may be the partially signed Bitcoin transaction. So
Hmm.
that's the UI part is different because here if you use smart contracts, everything you don't once you publish this, unless you want to, cancel it. You don't have to do anything. You just get matched. Just keep getting.
Yes. But I get it.
Like,
So at that point of it, so in the other part, when the match happens, the person has to actually give a
sign.
signature and
Yeah,
sign.
yeah, yeah,
Yes.
yeah. So that's a
Yes.
UI thing. Yeah. Oh, you can.
Okay.
Yeah, that's different.
That's why this one is preferable.
Yeah, I think this is the automatic thing because it matches the centralized exchange experience. I don't think I have if I sell 1,000 bitcoins every time it matches one, I have to sign. That's not good.
Yes, and this is the time when we can have agents automatically match your order,
Mm,
uh, get let's say takers for you and match it and then take their own fees.
mm. Yeah, I like the idea. Yeah, but yeah, I assume there's a lot of details to work out. I think I have done.
Actually, I haven't written one more constraint.
Uh,
Um, so in the contract constraint, we will also write the taker paying the fees, the percentage we haven't
oh yeah,
mentioned
yeah,
that.
that's using. If you can do this, you can always add the fees. Just another output, right?
Yes, yes,
Say some kind of percentage. Yeah.
yes.
Yeah. Okay. Cool. Yeah. I think that's a lot of information for me to process. I have to need to
Mm.
dive into this and think about it, and then probably I'll reach out again if I probably have more questions than answers today. Mm.
Hmm. Okay,
Yeah, but this is cool.
wonderful.
I think it's just yeah, it could be game changer. That's just my rough feeling. I don't know whether it can how complex this is or how expensive or but it looks to me is much better than the previous iteration generations of on-chain order book because the partial ordering is always a thing. Yeah, and there's no incentive to match, and the liquidity is never good, and you don't
Hmm.
have the contention issue because you are putting them in different UTXOs. So
Hmm. Yes, and let the market win. The
mhm.
market always wins. Right?
Okay,
Hmm. Hmm.
cool. I think anybody
Hmm.
else have some questions regarding this or
One very quick question regarding
yeah,
the
Domingo. Yeah.
STAS protocol. So I think there are like three versions, right, of STAS 20, 50, and 789. Do you guys use any in particular, and why?
No, we haven't looked into the two different versions of stars yet.
Okay, cool.
Is there something that we need to consider on that?
To be honest, I don't know. I only know that there are three of them, and that I'm just taking a look to docs.statstoken.com. I will share with you on the chat, and I don't. Yeah, so this is, for example, on
Oh,
the last one, but there are the other two, and I honestly don't know what are the differences between the three of them. I can see that 20 they explicitly mentioned the security tokens, but then on the 50 it tells about versatility, and the 789 is next generation utility token, but I don't know about the details. Sorry.
no, okay. Oh, yes, yes. They have the versions where they're adding more abilities to do um, other types of constraints added to the stars token output. Um, but yes, that the basic abilities remain the same of what we require in all the versions, the splitting and merging, just like Satoshi's have.
Yeah, I don't know if you are sharing the because I saw the pointer moved, so I don't know if you were trying to share anything or that was just casual.
No, no, just casual.
Okay, okay, no problem. Thanks.
Yeah. Also, I share, another article we wrote a long time ago was called that token swap, and it's also atomic. So it's similar to what you just mentioned here. It's not cross chain, but you make sure it's atomic, and you are swapping two assets on the same chain. Yeah,
Okay.
maybe worthwhile to check it out. Yeah.
Okay, I also shared the Miro link.
Yeah. Okay. Great. Okay. If not,
Okay.
you have to. Yeah, I just request access. Okay. Yeah. Great. Yeah.
All
That's
right.
other
Thank you so
information.
much.
Okay. Thank you. I'll probably get back to you with more questions. What if I
Okay.
need
Okay.
to digest a little bit? Okay. All right.
Okay.
If you want to, we just cover like tiny fraction of all the projects in some of code. If you want to, come back, or the teams want to show off the thing, always
Hmm.
coming back. We have the weekly call, so you're more than welcome to come back and show us more of the projects. Yeah,
All
but
right.
as
Yes.
said,
Yes.
we cannot finish it in one call. Seems a lot of project. This is good. Yeah.
Yes.
So
Yes.
okay, keep us updated. Okay, thank you.
All right. Thank you
Okay,
so much for
okay,
Thanks.
thank
joining
you
us.
everyone.
Thanks,
Bye.
Okay,
guys.
see you next
Yeah.
time. Okay,
Yeah.
bye bye.